This is Geometry Chapter 15, Lesson 1. Don't forget to subscribe, like, leave a nice comment too. Is there something else I'm supposed to say? I feel like there's 4 things. Hit the what? Notification. Turn on notifications. Thank you. Okay. Smash it. All right. Chapter 15. Geometric solids. To date, we have only looked at plane geometry. Geometry that lies on a plane. So 2 dimensions really is what we've looked at. We have looked at the area of a circle, and we've looked at the area of a regular polygon. But today we're going to talk about different lines and planes that exist in space. All right, I need an image. All right, so when we're talking about lines and planes, lines that exist on a plane, your book says there are 2 options. I'm going to tell you there are 3. There are really 3 options for lines that exist on a plane. Either they are parallel, and when lines are parallel on a plane, there's a constant distance between those lines and they never ever intersect. So that's one option. We have parallel lines. We have another option. We have lines that intersect and they're concurrent at one point. But I will tell you that there's another option in algebra. We have lines that are concurrent and dependent at every point. They're the exact same line. So they have the exact same slope, the exact same y-intercept. All right? And so how do we decide that it's a line? Do you remember 2? 2 points determine a line. That goes all the way back, right? And that's your first postulate. If we have 2 points that lie on a plane, then a line can contain them. That's very similar to your 2 points determine a line. All right? Now moving into 3-dimensional geometry, where do we see lines in 3 dimensions? Well, we can see lines on any singular plane, or lines are where planes intersect. Like the plane of this wall intersects the plane of that wall at that line, which is vertex after vertex. Does that make sense? Planes intersect. Where planes intersect, it's always they intersect at a line. All right? Now, where we have really 3 options of how lines relate in plane geometry, there's an added way that lines can relate in 3-dimensional geometry, and that is called lines can be skew. In 3-dimensional geometry, lines, look at the definition. Lines are skew if, I'm going to add something, it doesn't say non-coplanar. They cannot lie on the same plane because this only exists in 3-dimensional geometry. So they're non-coplanar and they do not intersect. They are neither parallel nor do they intersect. So they're not lying on the same plane. And you can see the image of the lines M and L on the roof. One is on the pitch of the roof where those 2 triangular planes meet. And the other one is on the base of the roof on the other side. They are neither parallel, but they would never intersect. The only way that lines can be skew is if they're non-coplanar and they have this constant distance between them because they must never intersect. All right, so look at my case. All right, so if I said this is a plane and this is a plane, and this would be the line where the plane exists. This line is not skewed to this line. Makes sense? Because they intersect, right? However, this line is skewed to this line. They lie on separate planes. There's a constant distance between them. Make sense? All right. So we have another option for the way lines relate. They are non-coplanar in three-dimensional geometry. They are non-coplanar. So because they're non-coplanar, that we don't call them parallel, because for lines to be parallel, they must lie on the same plane. All right. So we do not call non-coplanar lines parallel. We call them skew if, in fact, they lie on separate planes and they don't ever intersect. There's this constant distance between the two. All right. Does that make sense? So we have skew lines. All of this is introductory material for us to be able to talk about solids. All right, two planes can be parallel. Two planes can be parallel if they don't intersect. All right, so this plane is parallel to this plane because they would never intersect. And we know that although the image of a plane, the space that is taken up on this plane by this wall ends, the plane literally goes on forever in all directions. All right, and that would be the same here. But if we continued these planes, they still would never ever intersect. So two planes can be parallel if they never ever intersect. We can have a line and a plane parallel if they never ever intersect. But if we have lines that are non-coplanar and there's a constant distance between them, we call that skew. You see the difference? So non-coplanar, what we would consider parallel lines, we call skew. Two planes can be parallel. A line and a plane that can be parallel that are non-coplanar, as long as they are separated by a constant perpendicular distance between the two. Does that make sense so far? So that has to do with parallel. So we've talked line to line, we've talked plane to plane, and we've talked line to plane. Line to line, we call them skew. Plane to plane can be parallel, and line to plane can be parallel as long as there's a constant distance between them. Does that make sense? All right, now let's talk about perpendicular. All right, that's on page 620. A line and a plane are perpendicular if where they intersect, the line is perpendicular to every line that can be drawn on that plane. Like this line would be perpendicular to this plane. Because every line that I could draw on this plane would be perpendicular to that line. Every line that would intersect that line could be drawn everywhere. It would be perpendicular where it meets that line.
But does it form right angles?
Yes, it does form right angles. Yes, where the plane meets the line, it would form, because all the lines that you draw would be perpendicular to that one line. It would just be like a rotating line, right? So we're not changing the angle in relation to the line. We're just changing the perpendicular, right? We're rotating the line. The intersection point would be the exact same. Make sense? So when we're talking about a line and a plane being perpendicular, every line on the plane has to be perpendicular to that line. Look back with parallel. In order for a line and a plane to be parallel, they just can't intersect. So it's not like every line has to be parallel. Every line on the plane has to be parallel to that line. So when we're talking perpendicular, you have to be able to know that every line on the plane is perpendicular to that one line. Does that make sense? Look at the image. We have line L through the plane. Do you see that? The yellow plane, the top image. And you see the multiple lines. It doesn't matter how we draw the line. That line is always going to be perpendicular to L. Got it? All right. Two planes are perpendicular. If one plane contains a line, notice not every line, if one plane contains at least one line that is perpendicular to the other. All right, so this plane is perpendicular to this plane. This plane perpendicular to this plane. All I need is one line to prove that it's perpendicular to that one plane. But when we're talking about a line to a plane, I need every plane on the line to be perpendicular. Why? Why would that be the case? Because what if I did have a line and I could find one line on the plane that would be perpendicular to that line? Then that would not mean that every line on the plane would be perpendicular to it. Okay, y'all, this is a play on word. I mean, this is... So, line to plane perpendicular, every line on the plane must be perpendicular to the line. Got it? Plane to plane, I need one line perpendicular to the plane. Do you see the difference? Plane to line, every line must be perpendicular. Plane to plane, I need one line perpendicular to know that those planes are, in fact, perpendicular. Does that make sense? Anything other than parallel or perpendicular is called oblique. It intersects at any other angle. Well, all oblique lines intersect, so obviously they're not parallel. And they intersect at an angle other than 90 degrees. So a line and a plane can be oblique if where they intersect is not a 90-degree angle, which is probably true with most of these walls, actually, the way they construct them. And with our constructions, when we've done constructions and tried to make perpendicular lines, some of us are 89, 91, right? That would be oblique. Two planes are oblique if they intersect at an angle, any angle other than a 90-degree angle.